Question number 1. Solve the following system of linear equations using the eliminations method. So first for questions A, I'm going to label each of the equations as equations number 1, 2, and 3. So next, I'm going to choose variables to be eliminated. So in this case, I'm going to choose the variable y from equations 1 and 2, as both of them are having the same value. Therefore, it can be eliminated straight away. So I'm going to plus these two terms together. So plus minus here will become a minus. Therefore, 5y minus 5y is equal to 0. Therefore, the y will be eliminated. So for the rest of the terms here, I'm going to plus them together as well. So here, equations number 1 plus equations number 2. 7x plus 3x is 10x. And negative 3z plus 2z is minus z equal to 16 minus 8, which is 8. So these are going to label as equations number 4. So here we already eliminate the variable y. So next I'm going to choose another pair of equations, either equations 1 and 3 or 2 and 3. But I'm going to eliminate the y as well, because in equations number 4 we already eliminate the y. So in this case, I'm going to choose equations 2 and 3, which I'm going to eliminate the y. Now both of them, the y, the value is negative 5, the other one is positive 3. So now to equalize the y, the lowest common multiple for 5 and 3 is 15. Therefore, for equations number 2, I'm going to multiply it by 3. So the rest of the terms, you need to multiply it by 3 as well. And for equations number 3, I'm going to multiply it by 5. So here I'm going to write equation number 2 multiply 3. So here you're going to have 9x minus 15y plus 6z equal to negative 24. So this I'm going to label it as equations number 5. And for equations number 3, I'm going to multiply it by 5. So I'm going to have 25x plus 15y minus 35z equal to 0. So let us label this as equations number 6. So now look at the variable y for equations 5 and 6. To eliminate it, I'm going to add these two terms together. So it will be negative 15 plus 15y. So it will be equal to 0. So for the rest of the term, we're going to plus them as well. So here is going to be equations number 5 plus equations number 6. So here you're going to have 34x. So here is going to be positive 6 minus 35z, which is minus 29z equal to negative 24. So this I'm going to label it as equations number 7. Now look at the equations number 4 and equations number 7 that we have here. Now to find either one of the value here, we need to eliminate another variable. In this case, I'm going to choose the variable z. So for equation number 4, the z is negative 1 and 7 is negative 29. So first we need to equalize the value of z. So for equations number 4, I'm going to multiply each of the term by 29 to equalize the value of z. So equations number 4, I'm going to multiply it by 29. So you're going to have 290x minus 29z equal to 232. So this I'm going to label it as equations number 8. So now look at the variable z here. To eliminate it, we're going to minus these two terms. So minus minus here will become a plus, right? So negative 29z plus 29z is equal to 0. So for the other two terms, we're going to minus it as well. So in this case, I'm going to use equations number 8 minus equations number 7, as the value in equations number 8 is bigger. So 290x minus 34x, which is equal to 256x. So z has been eliminated. So 232 minus negative 24, minus minus become a plus. So you're going to have the answer of 256 as well. So x is equal to 256 divided by 256, which is equal to 1. So next, we're going to find the value of the other two variables. So here I'm going to substitute the x equal to 1, which we find here, into either equations 4, 7 or 8. Alright, so here I'm going to substitute it into equations number 4 to find the value of z. So 10x, so the x here, we're going to substitute it with 1, minus z equal to 8. So 10 times 1 is still what? 10, right? So negative z equal to 8 minus 10. So negative z equal to negative 2. So therefore z is equal to positive 2. So I already have two values of the variables. So now I'm going to substitute x equal to 1 and z equal to 2 into the equations that contain the variable y. So in this case, you can choose either equations 1, 2 or 3. So here I'm just going to choose equations number 1. So 7x, so the x I'm going to substitute it with 1 plus 5y minus 3z. So the z, we're going to substitute it with number 2. So equal to 16. So it's going to be 7 plus 5y minus 6 equal to 16. So 7 minus 6 is equal to positive 1. So we're going to move it to the right hand side. So 5y equal to 16 minus 1. So y is equal to 15 divided by 5, which is equal to 3. Question B. So first, let us label the equation first. So now, if you look at the variables x, y, z in these three equations, none of them are having the same value. Therefore, to eliminate it, we need to choose a variable and then we need to equalize the variables by ourselves. So here I'm going to choose the variable x to be eliminated. So first, let us look at equations 1 and 2. So for equation number 1, the x is 4x and equations 2 is x. So first we need to equalize the x. So for equations number 2, I'm going to multiply each of the terms by 4. So here I'm going to write equations number 2 multiply 4. So here we're going to have 4x plus 12y minus 16z equal to negative 28. So I'm going to label this as equations number 4. So now let us focus on equations 1 and equations 4. So now we already equalized the variable of x. So now to eliminate it, we're going to minus it. So 4x minus 4x is equal to 0. Therefore, here I'm going to use equations 1 minus equations 4. So 4x has been eliminated. So negative 12y minus the positive 12y, we're going to get negative 14y. This positive 3z minus this negative 16z is going to be equal to positive 19z. and 1 minus this negative 28 will be equal to 29. So this we're going to label as equations number 5. So here we already eliminate the variable x. So next I'm going to choose another pairs of the equations here. So here I'm going to use equations 2 and 3. And we are going to eliminate the variables x as well. So in order to equalize the x, equations number 2, I'm going to multiply each of the terms here by 3. So here I'm going to write equations 2 times 3. So you're going to get 3x plus 9y minus 12z equal to negative 21. So this I'm going to label it as equations number 6. So now let us focus on equations number 3 and equations number 6. So to eliminate the x here, we are going to minus it as well. So here I'm going to use equation 6 minus equations 3. So 3x will be eliminated. So positive 9y minus this positive y, it will be equal to 8y. Negative 12z minus positive 2z equal to minus 14z. And this negative 21 minus 5, you will get negative 26. So this will be our equations number 7. So now, let us focus on equations 5 and 6, 5 and 7. As both of these equations now, we already eliminate the x, so we already only contains 2 variables here. So next we can solve the equations 5 and 7 using the simultaneous leading equations. But first we need to choose another variables to be eliminated and equalize them. So here I'm going to choose the y to be eliminated. So 14 and x, the lowest common multiple will be 56. Therefore, to equalize the y, equations number 5, I'm going to multiply it by 4. And for equation 7, I'm going to multiply it by 7. So equations 5, I'm going to multiply it by 4. So here I'm going to get negative 56y plus 76z equal to 116. So let's label this as equation number 8. And for equations number 7, we're going to multiply it by 7. So here we're going to have 56y minus 98z equal to negative 182. So this one, let us label it as equations number 9. So now, we already equalized the y. So to eliminate it, we're going to plus these 2 terms together, which means for the other terms, we're going to plus it as well. So I'm going to write it on the right hand side here. So equations number 8, we're going to plug it plus with the equations number 9. So the variable y has been eliminated. So 76 plus negative 98z, it will be equal to negative 22z. And 116 plus negative 182 is equal to negative 66. Therefore, z is equal to negative 66 divided by negative 22, which is equal to positive 3. Next, we're going to find the value of the other 2 variables. So next, I'm going to substitute the z equal to 3. So into equations, either equations 5 or 7, even 8 and 9, to find the value of the y. So here I'm just going to choose equations 7. So 8y minus 14. The z here, we're going to substitute it with the value 3. So equal to negative 26. So this will give you the answer of negative 42, and we're going to move it to the right hand side. So it will be negative 26 plus 42. So y is equal to, so this will give you the answer of positive 16. Then we're going to divide it by 8. So y is equal to positive 2. Next, we're going to find the value of the x. So next, I'm going to substitute the y equal to 2 and z equal to 3 into either equations 1, 2, or 3 to find the value of x. So in this case, I'm just going to choose equations number 2. So x plus 3y. So the y, I'm going to substitute it with 2 minus 4z. So the z is going to be replaced by 3 equal to negative 7. So here you're going to have x plus 6 minus 12 equal to negative 7. So here is equal to negative 6. Move it to the right hand side. So x equal to negative 7 plus 6. Therefore, x is equal to negative 1. Question number 2. Solve the following system of linear equations using the substitutions method. So first, let us label the equations. So next, we want to choose a variables and express it in the other terms. Normally, we will choose a variable with the coefficients of 1. So when we express it in the other terms, the answer will not be in fractions form. So here we can choose either the y from equations number 1, or x, or y, or z in our equations number 2. So in this case, I'm just going to choose the x from equations number 2 and express it in the terms of y and z. So from equations number 2, so the x is equal to negative 3 plus y plus z. And I'm going to label this as equations number 4. So this equations number 4 is the one that I'm going to substitute into the equations 1 and equation number 3 at the x here. So first, I'm going to substitute equations number 4 into equations number 1. So 2x, so the x I'm going to substitute it with negative 3 plus y plus z. Later on, plus y plus 3z equal to negative 2. So next here, I'm going to expand it. So here I'm going to have negative 6 plus 2y plus 2z plus y plus 3z equal to negative 2. So next, we're going to solve for the like terms. 2y plus y is equal to 3y. Y and 2z plus 3z is 5z. So equal to, then we're going to move this negative 6 to the other side. Then it will be negative 2 plus 6, which is equal to positive 4. So this we're going to label it as equations number 5. So next, we're going to substitute the equations 4 into equations number 3. So 3x, so the x we will substitute it with negative 3 plus y plus z. So minus 2y plus 3z equal to negative 12. Next, expand this one. You're going to have negative 9 plus 3y plus 3z minus 2y plus 3z equal to negative 12. So next we're going to solve for the like term. So 3y minus 2y, which is equal to positive y, and positive 3z plus 3z, which is equal to 6z, equal to, so this negative 9, when you move it to the right hand side, will become a plus 9. So negative 12 plus 9 is equal to negative 3. So this we're going to label it as equations number 6. So now let us focus on equations 5 and equations number 6. Alright, so here you only have two variables here. So next we can solve it just using the simultaneous linear equations. So for here I'm going to equalize the y. So for equations number 6, I'm going to multiply it by 3. Alright, so here you're going to have 3y plus 18z equal to negative 9. And this I'm going to label it as equations number 7. So now let us focus on equation 7 and equations 5. So now both of them are having the same value of y. So to eliminate it, we're going to minus it. So therefore, here's equations number 7, I'm going to minus equations number 6. So when 3y minus 3y, the y is equal to 0. It will be eliminated. 18z minus positive 5z is equal to 13z. And negative 9 minus this 4 is equal to negative 13. Therefore, z is equal to negative 13 divided by 13, which is equal to negative 1. Now, next, I'm going to substitute the z equal to negative 1. Here, I'm going to substitute it into the equations number 6. Or you can also substitute it into the equations number 5. So here I'm just going to choose equation number 6 as the y here, the coefficient is 1. So y plus 6z. So the z I'm going to substitute it with negative 1. So equal to negative 3. So here is equal to negative 6. I'm going to move it to the right hand side. So it will be plus 6. So y is equal to positive 3. So next, we're going to find the value of the variables x. So next, I'm going to substitute the y equal to 3 and the z equal to negative 1. Here, I'm going to substitute it into the equations number 4, as here the x already being the subject of the formula. So x is equal to negative 3 plus y. So our y here is a positive 3. And then we're going to plus it with the z. So the z is a negative 1. Alright. Solve this and you're going to get the answer of negative 1. Question B. So first, let us label the equation first. So next, here I'm going to choose the x from the equations number 2 and express it in the terms of y and z. And later on, I'm going to substitute it into the equations 1 and 3. So here from equations number 2, the x is equal to 12 minus 4y plus 2z. So this I'm going to label it as equations number 4. So first, I'm going to substitute this equations number 4 into equations number 1. So here 2x So the x, I'm going to substitute it with 12 minus 4y plus 2z plus 3y plus 2z equal to 16. Expand this, then you're going to get 24 minus 8y plus 4z plus 3y plus 2z equal to 16. So next, we're going to solve for the like terms. So first here, negative 8y plus 3y. Here you're going to have negative 5y. And positive 4z plus this 2z is equal to 6z. So next, I'm going to move this 24 to the right hand side. So it will be 16 minus 24, which equal to negative 8. Here I'm going to label this as equations number 5. So next, I'm going to substitute the equations number 4 into equations number 3. So the x here, I'm going to substitute it with 12 minus 4y plus 2z. Later on, plus y plus 4z equal to 20. So here we're just going to solve for the like terms. So first, negative 4y plus y. So this equal to negative 3y. And this positive 2z, I'm going to plus it with this 4z. So I'm going to have 6z equal to, so this 12, when you move it to the right hand side, will be 20 minus 12, which is equal to 8. So this I'm going to label it as equations number 6. So now let us focus on equations 5 and equation 6. So they only contain two variables, which is the y and z. So now we can solve it using the simultaneous linear equations method. So if you look at these two equations, we are having the same value for the z here. Therefore, I'm going to choose to eliminate the z later on. So to eliminate it, I'm going to minus these two terms. Therefore, here I'm going to write equations number 5 minus equations number 6. So first is negative 5y minus this negative 3y. So the negative later on become a plus. So it is equal to negative 5y plus 3y, which is equal to negative 2y. Alright, z will be eliminated. So negative 8 minus this 8, we're going to get negative 16. So y is equal to negative 16 divided by negative 2, which is equal to positive 8. So next, I'm going to substitute the y equal to 8 into either equations 5 or 6. So here I'm just going to choose equation 6. So negative 3y. So the y, I'm going to substitute it with 8 plus 6z equal to 8. So here is equal to negative 24. So when you move it to the right hand side, it will be plus 24. So z is equal to, so here is 32 divided by 6. Simplify this, you're going to get 16 over 3. So last one, we're going to find the value of x. So I'm going to substitute the y equal to 8 and the z equal to 16 over 3 into equations number 4, as the x already become the subject of the formula. So x equal to 12 minus 4y. So the y, substitute it with 8 plus 2z. So the z, we're going to substitute it with 16 over 3. So here, just solve it using your calculator. It will give you the answer of negative 28 over 3.